Hello everyone, this is Geetha Priya from R.M.D.E. Engineering College. In this lecture, we will be seeing about schedules from DBMS. Schedules are nothing but the sequence of a transaction. For example, you consider multiple transactions are running concurrently. So when a concurrent operation happens, there may be the inconsistency of data may happen. So to avoid the inconsistency, we are going to arrange or we are going to sequence the transaction. So this process will be known as a schedule or scheduling. So these are the types of schedules. They are serial, non-serial, recoverable, non-recoverable, cascadeless, and the other one will be the cascadeless rollback. The other one is strict schedule. So serial schedule. Serial schedule is nothing but in this table you can see that we are having two transactions in one schedule. So transaction 1 has three commands: read A, and you're going to do an update operation, or you're going to process the A, and then you're going to write the A. So after completion of this transaction only, the transaction 2 has been started. So this type of schedules will be called as serial schedule. That is completion of after completion of one transaction, then only the other transaction will start. So this is your serial schedule. The next one is non-serial schedule. The same schedule with two transactions, but here you can see that in transaction 1, the transaction 1 has not completed its transaction completely before that transaction 2 has started its process. So when there is here you can see that the read A, and then A is going to do A is doing some process, but before writing the updated one, the T2 is reading the old data of A. So here the inconsistency of data will happen. So this type of schedule is called as non-serial schedule. The next one is recoverable schedule. So in this table, after completion of the T1, the T2 has been started. So this will be coming under serial schedule also. But why this is said as recoverable schedule? Here, after the completion of T1, it has been given a commit command. So commit is used to save a transaction completely in the database. So here you can say that the write A, the last update of A has been permanently saved in your database. So no change is going to be happen in this transaction 1. So depending upon this transaction 1, transaction 2 has started a process. So if any, there is no chance of inconsistency in this data. So this type of schedule is called as recoverable schedule. The next one is non-recoverable schedule. Here you can see that T1 has started a transaction, but it doesn't give any commit operation here. But before giving a commit, T2 has depended upon T1 and read the A and then done a process, and it committed an operation. So now T2 operation has been committed, that is stored permanently in the database. But after the commit operation of T2, T1 has aborted its transaction. So when T1 abort its operation, everything will roll back and read A. The first line will be, that is the transaction 1 will roll back to its original state. So now the T2 which dependent on T1 is stored a wrong data in the database. So this leads to a inconsistency of data. So this type of schedule will be called as non-recoverable schedule. So T2's data cannot be recoverable. It is stored a wrong data. The next one, cascading rollback. So cascading rollback. Here in this schedule, we have taken three transactions. So T1 is going to do an operation. Depending upon T1, T2 is going to start an operation. And depending upon T2, T3 is going to do an operation. But here, the same as non-recoverable schedule, after T1 transaction, even before committing the operation, T2 has depended upon T1 and started an operation. Again, depending upon T2, T3 has started an operation. But you can see here no one has committed the operation. So this cannot be coming under non-recoverable. Once any of one transaction has committed the data and then the other one aborted, then that lead to non-recoverable. But here luckily no one have committed the operation. So this can be taken to the original state. To go to the original state, we will be doing a rollback operation. So only this is called as cascading rollback. So now T1 has done a process. Depending upon the last write of T1, T2 has started a process. After writing A in T2, depending upon that, T3 has done an operation. So after T3, T1 has aborted his operation. So once T1 aborted the operation, it will be rolled back to the original state. So once T1 has been rolled back, then T2 should also roll back to the original state, and T3 should also roll back to the original state. So here the thing is, if two or more transaction is depending upon each other, any one of the transaction is rolling back, then all others should also roll back to the original state. So this will be called as cascading rollback. Then cascadeless rollback. Here same, T1 is doing an operation and committed the operation. Depending upon T1, T2 is doing operation and then committed the operation. After committing, depending upon T2, T3 has started an operation. Now, suppose, for example, an abort operation is going to happen. Once you are committing the operation, there is no way to go back or no way to abort the operation. For example, in this table, I am giving you T1 is aborting the operation. No change will happen, so that T1 don't want to roll back. So T2, which is dependent on T1, should also no need to roll back. Same T3 also don't want to roll back, because after the commit operation only T2 has started the operation. Once committed means the data has been permanently saved in the database. So nothing will be changing, so no inconsistency is there. So once a transaction has given a commit operation, the other transaction can depend on the other. So this type of schedule is called as cascadeless schedule. The last one is strict schedule. This is somewhat similar to cascadeless schedule. In a schedule, two transactions are there. T1 has done an operation and committed an operation, and then giving a commit operation only. The T2 is depending upon T1 and doing an operation. The thing is, suppose a transaction is going to depend upon another one transaction, it should depend one and only if the previous transaction has committed its operation. If it is not committed, then you should not depend upon the previous transaction. So this is your strict schedule. Thank you.